So, hello children, hope you guys are fine and are staying safe at home. So, welcome to the third class of science. So, before I move on to the chapter, I would like to conduct a small test for you. So, just go through these questions and try to analyze the answer on your own. So, the first question, the strength of a force is usually expressed by its dash. So, this I have already discussed in the previous class. So the options are option A momentum, option B magnitude, option C strength, and option D none of the above. Shall we find out the answer? Is it option C? No, it's not option D as well. So it's not option A. So final answer is option B magnitude. So as I said already, so if you want to determine the strength of a force, so we can easily we usually express through its magnitude. Magnitude is nothing but the strength of the force. Okay, so the second question, force applied on the same direction dash to one another. So in the previous class I discussed, I said whenever we apply any force in the same direction, so what will happen, whether it will get added up or it will get subtracted. So it gets added up to one another. So the next question, the net force applied on the opposite direction is the dash between the two forces. It is the difference between the two forces. So when we are trying to apply the force in the opposite direction, okay, so it nullifies the force of one object with another object. So as I quoted various examples, the tug of war game, and even when a person tries to push the table in the opposite direction, so what will happen, all those things I discussed in the previous class. So from that only we can conclude that when two person try to apply the force to an object in the opposite direction, then what will happen, we have to subtract, we have to find out the difference between both the forces. Okay, so then only we can able to easily determine the net force, the final force. So let's do a quick recap of what we have learned in the previous class. So as I said already, force applied on the same direction adds to one another. So whenever we apply force in the same direction, like how I quoted various examples, how when a man tries to push us the car from behind, from the back, so he is only applying the force on one direction. So another man, if he joins in, so what will happen, his force also gets added up because he is also trying to push the car in the same direction. So when more persons join in, what will happen, more force will get added up. So whenever in any object, when you try to apply the force to push it into the same direction, then what will happen, the force will get added up to one another. And another thing what we discussed, the net force applied on the opposite direction is the difference between the two forces. So as I said already, when we try to apply the force to the same object in the opposite direction, then what will happen, so you need to calculate the total force by subtracting the force applied by the first person and the second person, then you will get the net force. So the third one what I discussed, the strength of a force is usually expressed by its magnitude. So how can we determine the strength of a force? So by determining its magnitude of an object. Okay, so now let's move on to the third part of the chapter, that is force and pressure. Okay, so before we move into the chapter, we must learn what are the learning objectives of today's class. So in today's class we are going to learn more about forces. So we are going to understand one particular concept, that is how a force can change the state of motion. Okay, what do you mean by state of motion? So have you ever heard this term motion in your previous class? I hope you guys would have remembered when you were learning about in 7th standard also, you would have learned about motion. Motion is nothing but movement of an object from one place to another place, right? So by keeping the state of motion, that is when an object moves its position from one place to another place, how the force reacts, or how the force enacts on that particular object, that we are going to learn in today's class. Okay, so let's move on to the class. So before I dive into the class, I'd like to show you a small video to explain about how a force can change the state of motion. Okay, so observe this video.
A force can change the state of motion. Force can move a body which was initially at rest. It can bring a moving body to rest. It can change the direction of a moving object, and it can change the speed of the moving objects.
So as she said, force can move a body which was initially at rest. So there are two things, right? When an object does not move, when an object is kept in a particular place, then we can consider that object at rest. For example, if I give you a football, if you keep the football on the ground as it is without doing anything to the football, we can say that that football is at rest, right? But if you apply a force to move that football from one place to another place, then we can consider that football as it is in motion, right? So a force can move a body which is initially at rest. So with the help of the force, we can move a body, we can move an object which is at rest, and it can bring a moving body to rest also. So we can even stop that moving body, like if someone is trying to kick the ball, and if you try to stop by placing your hand or foot, so it will again come to rest, right? So you can even change the moving body, that is the object which is at rest we can move, or the moving body also we can bring it down to rest. Not only that, the force can also change the direction of moving object, and it can also vary the speed of the object. Okay, so all these things a force can do with the object. So let's find out how we can do all this.
Let us understand this from an example. Take a ball of some soft material and do the following tasks. Place the ball on the floor and give it a push. What do you observe? You observe that it starts moving. Now push the ball in the direction opposite to the ball. What will happen? It will stop. Now push the ball again so that it starts moving. Then give it a push at some angle. What happens to the motion of ball? The direction of motion of the ball has changed. In the last, take a ball between your palms and try to push. What do you observe? You observe that the ball squeezes. A change in either the speed of an object or its direction of motion, or both, is described as a change in its state of motion. Thus, a force may bring a change in the state of motion of an object. What do you do when your football gets deflated? You take it to some cycle repairing shop where it gets pumped and comes back to its spherical shape. Hence, the shape of a deflated football can be changed by inflating it. When you inflate a football, you apply a force on the pump. Hence, a force can change the shape of an object. Also, if you keep inflating the football, then its size will keep on increasing. Hence, we can conclude that the force can change the size of an object.
So through this video, what we understood, so with the help of the force we can move an object which is at rest, and not only that, we can also stop the object which is in motion. So a man was trying to push the ball, and if he just bring the hand at the other end, so after it gets hit on the other end, so what will happen? The ball will stop moving, so it will come back to rest. So instead of stopping, if I push it in some other direction, so what will happen? The ball will start moving in some other direction. So that also a force can be done. I mean, with the help of the force, we can also change the direction of an object. And not only that, we can also change the shape of an object by applying a force. Okay, so in the end of this video, they have quoted with an example. So when a football gets deflated, okay, when there is no air present in the football, so if I again wanted to inflate the football, so what we can do, we can just pump it out using a cycle pump. Okay, so as the air gets blown in, so what will happen, the football will again come back to its normal position. So we can also change the shape of an object. So all these we can do with the help of the force. So now what it is actually, let's find out. Okay, so here are few more examples which I will quote regarding the state of motion. For example, if a footballer tries to kick the ball, okay, so in this case the footballer is trying to hit the goal. So since the ball is not stopping, actually it's not being stopped by anybody, even though the goalkeeper is trying to stop the ball, but he could not able to reach the ball. So the ball is moving in the same direction with which the force was applied, so he can able to hit the goal easily, right? So the speed of the ball has not decreased, so since the ball is moving in the same direction, he can able to hit the goal. Whereas I'll quote another example, you can see this here. When the player is kicking the ball, so the goalkeeper, what he did, he stopped the ball, he managed to stop the ball. So instead of hitting the goal, what happened, the ball stopped or moved in some other direction, right? So here these observations suggests that a force applied on an object may change its speed. Okay, so what do you infer from this example, that if the ball keeps on moving in the same direction where the force is being applied, then there will be no change in speed, it will keep on moving. Okay, even when you do cycling, when you try to pedal it fast, okay, by applying more force, it will keep on moving, right? But if some hindrances comes, okay, if a stone or if somebody else came in front of you while you are driving, so what you will do, you will immediately apply the brake. Okay, so what will, at that time what will happen, the object will stop moving, it will come to rest. The same way here also, in the case of football, when the footballer tried to hit the ball, so if the ball just moves in straight, you can able to easily reach the goal, you can able to hit the goal. But if the goalkeeper tried to save the ball, and if he managed to save successfully by whatever, by using his hand or leg or whatever the body part, so what will happen, the ball will not reach its destination, instead it will either change its direction or it will stop. Okay, now what do you infer from this? So keep this in mind, if the force is applied on the object, if the object is in the direction of motion, then the speed of the object will increase, as I said earlier. So in the first case, when the footballer hits the ball, so the force in which, the direction in which the force is being applied, if it is not deviated, then what will happen, the speed of that football will increase, the speed of that object will increase. If the force is applied in the direction opposite to the direction of the motion, so I actually hit the ball, so when the goalkeeper is trying to save the ball, he is also applying his force, right? So he is applying force in the opposite direction of the object. So as soon as the ball hits the goalkeeper, so what will happen, the ball, instead of reaching to the goal, so it will stop, or it will change its direction, or it will decrease the speed of the object, right? So that results in the decrease in the speed of the object. So these 2 points, please keep that in mind. Now let us quote few more examples for you. In the first example, you can see here, in those days it was just like a model of a wheel, or we can also call it as the model of a cycle. Okay, so when we pedal it, okay, depending upon the speed with which we pedal, the object starts moving or rotating. The same way, if I try to pedal it more, I mean, if I try to apply more force in pedaling, so I can able to increase the speed of the object. And that's the reason why even you can see in those days, in our childhood days, we used to play using the cycle tires, waste cycle tires, by keeping one stick. The more force we apply, the more force by which we try to hit the tire, okay, the more faster it will rotate and we can able to move it, right? So when we apply in one direction unidirectional force, then what will happen, the speed of the object will increase. So let us see few more things. So I'll give one more example. Let us think of this activity. You can try to do it on your own. Take a ball, cricket ball, and a meter scale with you. So if I try to hit the ball, okay, try to just analyze whether the application of a force can change the speed of the object. So due to the application of force in another direction, will it vary the speed? So if I try to hit the ball to the scale, so the ball comes and hits this scale. Now tell me whether the ball will move again in the same direction or it will move in the opposite direction. So what will happen to the ball? The ball will absolutely obviously try to move exactly, it will move back into the opposite direction, right? It will not move like this. So it will come back like this. After hitting, it will completely come back to the opposite direction and it will come to rest. So what is actually happening now? Initially when it was being hit like this, the speed of the object increases, okay, and now when it hits the scale, so what will happen, the scale will apply an opposite apply the force in the opposite direction. So as a result, what will happen, the speed of the ball will slowly decrease when it comes back to the other end of the or other position or in the opposite direction, right? So the speed varies when we apply a force into the opposite direction. Please keep that in mind, never forget this. Okay, now let us see few more examples. So even when we play volleyball or throw ball, okay, so a player will try to hit into the opposite player with a greater force, then only he can able to win, right? So if he just try to hit it, I mean by applying lesser force, what will happen, it will just go normally in the same speed. So other person, if he tries to apply more force in the opposite direction, okay, if the other player cannot able to resist the force immediately, okay, and that's the reason he can able to easily win the game, right? In second thing, we can even change the direction of the force, not only the speed, we can also change the direction by using the force. Like for example, here you guys used to watch the cricket, right? Okay, obviously cricket is the favorite game for everyone. Have you ever seen many players, especially like MS Dhoni and all, whenever he tries to hit the ball, okay, especially his helicopter shot, when he tries to hit, he applies greater force, and the direction with which he hits, okay, the speed of the ball also increases, and the direction of the ball also, he can able to manage to hit it in any direction. So we can able to not only change the speed of the force, I mean change the speed of the object, we can also apply the force to change the direction of the object. Okay, so with this example we can conclude that a direct, I mean with the help of the force, not only we can change the speed of the object, we can also able to change the direction of the object. Okay, now here we can conclude that a change in either the speed of the object or its direction of motion or both is described as a change in state of motion. So here if we change the speed or the direction or both, so sometimes we can only change the speed, sometimes we can change both, we can change the direction and speed. So in general we call this terminology as change in state of motion. Okay, So thus a force may bring a change in state of motion of an object. So with the help of force, what we can do, we can bring the change in state of motion of any object. Okay, so what is the state of motion? So state of motion of an object is described by its speed and the direction of the motion. So when do we call it as state of motion? So when we calculate the speed and the direction of the motion, we can consider that it is, we can call it as state of motion. The state of rest is considered to be as the state of zero speed. If any object is at rest, then we can call it as state at rest, or we can also call it as no speed is being applied, or we can say zero speed. An object may be at rest or in motion, both are its state of motion. So even if the object is at rest also, we can consider it as a state of motion only. We can consider it as the object is at rest, that's it in general terminology. Even when you ride the bike, you can see in the odometer, we can able to exactly determine the speed of that object with which it is moving, right? So even if the bike is at rest, we can say that it is in zero speed, it is in state of motion, it is in state of rest actually. Okay, we can consider it as state of motion. Now you can ask, okay, how can we consider the object which is even at rest, we can consider it as state of motion? I'll quote an example for that. Like for example, if you take any hard object like a very heavy table in your home, and you try to apply the force to move it, if your weight is not enough, if your momentum is not enough to move that table, whatever you try to do, you won't be able to move it unless and until you have to bring an object which has greater force capacity to move, right? Not only that, even in your home, the walls which are being built, can you able to move the wall? No, right? Whatever the force you apply, whatever you try to push, you cannot able to move the wall from one place to another place, right? So we can consider that an object which is at rest also, okay, its speed is actually zero. We can consider it as it is in zero speed, which is also a state of motion. Okay, so I hope you guys would have understood today's class. So let's do a quick recap on what we have learned today. So if the force applied on the object is in the direction of the motion, the speed of the object increases. As I said, when you're applying a force in the same direction of motion, then the speed will increase. If the force is applied in the direction opposite to the direction of motion, then it results in the decrease of the speed. A change in either the speed of an object or its direction of motion, or both, we can call it as change in state of motion. So here is an assessment for you. So just go through this question. What do you understand by the term change in state of motion? So as just now I said, I gave a definition also. So you try to write the answer on your own. And second question, give few examples of force acting in the same direction of motion of object. So you have to quote few examples where you can apply a force in the same direction of the object. Okay, so this answers you can write it on your own and just submit it in the WhatsApp group. Okay, you can write it on your notebook and you can publish it. Now here is a home fun for you. It is like an activity for you right now. A boy is just like a higher order thinking. You have to answer it on your own. So a boy applies greater force using his hand to push the wall, but he is unable to push the wall or change its direction. Can we consider it as a state of motion? Okay, so try to find out this answer. Okay, whether we can consider this as a state of motion or not, you have to try to find out the answer and just publish it in your WhatsApp. Okay, so thank you children, hope you guys would have understood this today's session. So till we meet next time, take care children, have a good day, bye bye.